New Chapter 4, Section 2, we're going to be looking at applying congruence and triangles. And so when we take a look at the first example, it says when two polygons are congruent, all of their corresponding parts are also congruent. And so this is kind of what it looks like. Make sure you mark your triangles the way I'm marking my triangles, okay? It's just going to help for understanding. So for example, if I say angle A is congruent to angle F because they're corresponding, those parts are corresponding, I'm going to write angle A and then congruent and then angle F. Right? And then I take a look at angle B. Notice how I'm marking it a little bit different. That's congruent to angle E because they already told me those triangles are congruent. So angle B congruent to angle E. And then finally, angle C is congruent to angle D. Okay, so if the triangles are congruent, their parts are congruent to each other. Notice how that my letters that I write down, they're capital letters, okay, because they're vertices. Now that I've got the angles, I can start talking about the sides. So I can say side AB is congruent to side what? Okay, so I'm going to say FE, and this is why. It can be EF, I get it. However, you're going to notice that, you see how this A is a 1 hash? F is a 1 hash. So you need to make sure that if I label it as AB, that you label the other side as FE so that the corresponding parts are written the same, okay? And then I do line segment. I'm going to go BC. And what would be the side on the other triangle that's congruent? ED, very good. And then finally, I'm going to do AC. And that's going to be congruent to, that's correct, FD. Okay. So you can't just write down any letters. They need to be like, okay, this one's the same on this one the same on the other one. The order in which you name two figures is very important. So for example, let's say I start with W on this shape. I'm going to write WYAST. I can go, this is going clockwise. I could go counterclockwise if I want to, but I'm not going to jump like WSTY. I'm not going to do that. They've got to be in order. You can choose W first, you can choose Y first, it doesn't matter. Now that we're going to name that way, what vertice on the other shape is the same? Yes. That's correct, U. So U is on this one. And now I need to be careful. I picked W and then Y, and so I'm going to go W, and what would be the next letter? R. So it's R, B, H, P. So the order in which you name your shape matters. Questions on that? All right. If quadrilateral WSDR is congruent to YHJN, name the corresponding congruent parts without drawing a picture. So what you're going to do on this, I always name the vertices first. So angle W then is congruent to angle what? Y. Angle S is congruent to angle H. Angle D is congruent to angle J. And angle R is congruent to angle N. That's right. So the sides are not, or I should say the angles are pretty easy. The sides can get a little bit trickier. So I'm going to go WS is congruent to, so I'm picking these two. What would be the ones that are congruent on the other one? Yes, YH. Okay. Now let's go and let's name the next one. So SD is congruent to HJ. And DR congruent to JN. Okay, now I've got a fourth side because it said it was a quadrilateral. It also has 4 vertices, so I know it's going to have 4 sides. So I'm going to go line segment WR is congruent to line segment YN. That's correct. You'll notice I picked WR, and so I'm going to pick YN in that order. Any questions on this? All right. I'm going to keep going. Note that you must have all corresponding parts and angles and sides in congruence in order to say the polygons are the same. So again, they need to be in order. Here is one of the congruence, or one of the theorems that we're going to use in our proofs. Now, if you remember back in chapter 2, I gave you, a purple sheet of paper, and you wrote down all the different things that we could use in a proof. This would be something you could add to that sheet. And what it says is if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. So you'll notice that I've got a right angle, I've got a right angle, I have a 1 hash and I have a 1 hash, those are congruent. And so I know that that third angle is also congruent. And that's really important to note. Okay, you will be using that quite a bit in proofs. And it's called the third angles theorem. Remember that the most common reasons for proofs are, and we've talked about it before, given, reflexive, transitive, or substitution, definition of vertical angles congruent, or a definition of parallel lines, something like that. We have vertical angles are congruent. We also have if parallel lines, then alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Consecutive interior angles are supplementary. Okay. We also have if, for all those reasons, then parallel lines. So those are some things you might want to add to that purple sheet so that when you're doing your proofs next week, it'll be easier. Okay. All right, here's some examples. We need to find X and Y. So what do you want to do? Yeah. Say that one more time. Oh, okay. So because this is 35, this is 35. That is correct. And then, yep, you're right. We're going to go y plus 70 plus 35 equals 180. And that's the triangle sums property that we did the other day. Y plus, I got 105 equals 180. So y gives me 95 degrees. Okay, so that is 95 degrees. So now how do we find out x? Yeah. Okay, I can put 95 here. That is correct. Yes.
Wouldn't that be 75?
Yeah. It would be 75 because it's that other angle. Notice that this angle here and this angle here is not marked, so they're congruent. So I could just say that x equals 70 degrees, and there's no work shown. You don't need to show work. Questions? Yes, no, maybe, right?
Why be 75? Because 180 minus 25.
Did I'm sorry, it's not 975. I'm sorry, thank you. I'm glad you caught that. It's 75. Thank you. My bad, I added wrong. There we go. Is that better? Yes? Yeah, thank you. You're right. But X is still 70. Yeah, good. I'm glad you said something. All right, let's keep going. Here's X and Y on this one. How do I solve for this? Yeah. Okay, so this is 4x minus 8 because it's the same as this angle right here. Okay. And then what? Yes. Okay, so this is 90 degrees, this is 90, this is 90. So I can take this left triangle and go 4x minus 8 plus 38 plus 90 equals 180. So 4x plus 120 equals 180. 4x equals 60, I heard someone say. Yep, so x gives me 15. Very good. Yep, 15 degrees. All right, I got x. How do I go finding y? Yes.
You can do 4x minus 8 plus 2y plus 9 equals 180 and then substitute the 15 in here.
Very good. Yeah, absolutely. So what she's saying is I can take my 4x minus 8 plus my 2y plus 90 equals 180. And then she said, I know what x is because I solved it down here, and I'm going to put in 15. So 4 times 15 minus 8 plus 2y plus 90 equals 180. Okay, I get 60 minus 8 plus 2y plus 90 equals 180. So 60 minus 8 plus 90 gives me 152, is that right? 142? Okay, subtract 142. 2y gives me 38, is that right? Okay, so y gives me 19. 19 degrees because I'm finding angle measure, right? Questions? Yes, sir. Good. Yep, that's another way of doing it. Very good. So he mentioned, don't I know that if this one is 90 and this is congruent to this, can I say that this is congruent to this and set them equal to each other and solve? Yes, you can. So if you can see it, great. If you can't, is it wrong? Absolutely not. As long as you show your work and you can set it up, it's fair game. You can definitely do it that way. Any questions? All right, that's it for 4-2. Let me know if you have questions.